Hey guys, welcome back to the continuation of the chapter moles and chemical calculations, moles and stoichiometric calculations. Champions, we have done this question, I believe, in the last video, and I am going to continue from the same worksheet which I have compiled it for you people. I am right now on the next question. Okay, so this question is saying, I am just going to zoom it a little bit so that everyone can uh, be able to look into it very carefully. All right. Okay. Okay. All right. So this is okay. Sodium hydrogen carbonate is found in baking powder. What is the formula of sodium hydrogen carbonate? Is NaHCO3. All right. And then we can say this thing that when sodium hydrogen carbonate is heated, forms three products. So this is just heated to give you sodium carbonate and water along with carbon dioxide. We can look into it right now, this equation, that this compound is initially one thing, that is nothing is going to reacting with it right now. It is just heated. So such type of the processes, such type of the reactions in which a compound is undergoing a process to give products by heating, that type of the reactions are called thermal decomposition, decomposition process in which heat is given. Thermal decomposition. Name the type of the reaction that takes place when sodium hydrogen carbonate reacts in this way, called as thermal decomposition. Calculate the volume of carbon dioxide formed at room temperature and pressure when 12.6 grams of NaHCO3 is heated using the following steps. Determine the mass. Okay, so here he is just asking this question by giving you all these steps. Guys, can you look at there right now? Examiner in these type of the questions can give you some steps and can ask the question at the direct point as well. Instead of giving all these steps, he's just giving you space to calculate this answer. So you need to go through all these steps one by one, and then you have to reach this answer. Let's see the number one point. Okay. Determine the mass of 1 mole of NaHCO3. It means he is asking about MR value, relative molecular mass. Okay. 23 for sodium, 1 for hydrogen, 12 for carbon, 16 times 3 for oxygen. The total is becoming 84. All right. Calculate the number of moles of NaHCO3. Moles is equal to mass over MR slash AR. Here we are going to use MR because we are looking into a compound which is more than like a combination of more than one element. Compound itself is a definition having a combination of more than one elements chemically combined with each other is called a compound. So its mass is 12.6 given over here, and its MR value is 84 calculated here. The answer is 0.15 moles for this question. Now the next point is determine the number of moles of carbon dioxide formed. Guys, can you look at there in this equation? It is, I am just highlighting this equation. Okay, and this equation is telling you that 2 moles of NaHCO3 is giving you 1 mole of carbon dioxide. So it is 2 is to 1 ratio. We can say this thing that we are going to divide these moles by 2 to calculate the moles of carbon dioxide. So it is 0.15 divided by 2 is giving you 0.075 the moles of carbon dioxide. Okay, done. I have told you already in the previous videos as well that whenever examiner is asking you something related to this, you are going to calculate the moles first and then you are going to calculate the next point. Okay, so right now we can say this thing that 1 mole of carbon dioxide is 24 decimeter cube, whereas 0.075, which examiner has given you, is giving you X volume. So you are going to do the cross multiplication and the answer is 1.8 decimeter cube. Okay, now the next point, lime water is aqueous calcium hydroxide. Carbon dioxide turns lime water milky because of the white precipitate formed. In this case, write down the formula for this compound. So the formula for calcium hydroxide, it is calcium hydroxide, and what is the white precipitate? It is calcium carbonate. Okay, here I'm writing this equation as well at the top. Okay, so it is calcium hydroxide. When we are going to pass it, like a carbon dioxide is passed through it, as a result, it is going to give you white color precipitation of calcium carbonate along with water as well. Okay. So such type of the reaction is happening over here, and that is a test for identification of carbon dioxide as well. Okay, right now I am on another question. It is also a question in which we are going to calculate the water molecules as water of crystallization. Those students who have seen this question very carefully in the last video, they must be understanding this question, and they are finding this question an easier concept. Guys, can you look at here right now? In this question, examiner is saying in an experiment 1.61 grams of Na2SO4 dot XH2O. Okay, so this is the compound is heated. Heated means that it is again like you are going to heat that compound, and compound is converting itself into like a compound without water, and water molecules are released as gas, I mean to say as steam, until all water is given off. The mass of Na2SO4 remaining is like what, 0.71 gram. And then we can say this thing that here examiner has calculated, has given you the masses of like MR values for Na2SO4 and water in the start of the question. Okay, then what we can say, examiner is asking the value for X, which is the number of water molecules adjusted with the compound as water of crystallization. Let's see the question stepwise. Okay, calculate number of moles of Na2SO4 remaining. Okay, and Na2SO4 remaining is like 0.71. Okay, so moles is equal to mass over mr slash ar. They are asking us to calculate the moles for Na2SO4 for the remaining one, so it will become 0.71 divided by 142, which is the mr value for this compound. So it is 0.71 divided by 142 is giving you 0.005, which is the mole value for this Na2SO4. Then examiner is saying to calculate the mass of this, so it is the initial mass minus final mass, so it is 1.61 minus 0.71 is giving you 0.9, which is the mass for this. Now examiner is saying calculate the number of moles of water given. Okay, number of moles of water is 0.9 divided by its mr value, which is 18, so it is 0.05 in that case. Okay, so we have calculated the moles of water in this case. Now the formula which we have implemented in the previous question as well, number of molecules of water as molecules of as water of crystallization, you may say number of molecules of water as water of crystallization will be equal to number of moles of water divided by number of moles of compound. Guys, can you look at here right now? I can say to you very clearly that in this compound, this is the number of water molecules, which is equal to moles of water divided by moles of compound. Here, this is an example deliberately I have taken to tell you that it can be an answer as one as well. So 0.05 is the moles for 0.05 is the moles for like a compound, and 0.05 is the moles for water as well. I believe that there is some problem in this calculation. It is 0.005 is the moles for that. Okay, so we are doing the calculation again to tell you that it is some issue over there while writing this. Okay, I am just erasing it, and it is same actually. Okay, and problem is here, it is 0.00 point uh, 0.05 divided by 0.005, which is equal to 10 in this case. So this, there is some printing or some issue with this, and I am going to make it correct. Okay, so 0.005, this is this. Okay, please don't get upset related to this. This is this, whereas this is this. Okay, so the answer will become 10, and answer is here dot 10 water molecules, 10 water molecules. So Na2SO4 dot 10 water molecules as water of crystallization in this compound. Next is the question which is more attention demanding. Guys, can you look at there right now that there can be 4 to 5 MCQs in specifically in 5070. No doubt examiner is asking questions in IGCSE's exams as well, but in MCQ paper, examiner is consciously asking some calculations which are requiring more time. So it is my guide to all of you that whenever you are solving such type of an MCQ paper, please leave such type of the questions initially. Solve those questions which are not that much time requiring and not that much focus requiring. So please more attention and more hard work is not required for those questions. So please solve all those questions first and then leave those questions, and then you people will be left with few questions with longer interval of time, and hence things can become more manageable. Now look at here right now at question number 5 on page number 5. I am right now on an MCQ. Examiner is asking, here is the working for this. Do we need to do the working for the MCQ paper as well? Yes. Examiner will give us space for working. Yes. Examiner is interested in the MCQ sheet only, which is also called as bubble sheet, which is also called as MCQ sheet. The spaces are given below the option like A, B, C, D. Four options will be there, and there will be spaces. You need to shade it with a pencil. Remember this thing that if you are not shading it with the pencil, marks can be deducted in that case as well, because the paper of MCQ will be scanned only. Okay, a scanner is going to check that, and the scanner is fed with a program to solve with to detect the pencil shading. So please, if you are writing something wrong, you have a chance to erase it and to make it correct in the next thinking process. Okay, so these are the options related to MCQ paper. Okay, if you are going to appear for your school exam as well, please do the same practice, because it will be helpful to you to prepare yourself for the Cambridge examination. Okay, so right now I am on question number 5. The equation for the decomposition of calcium carbonate is shown. You can check this thing. It is calcium carbonate converting itself into CaO and CO2. I am right now going to highlighting this thing. Okay, look at here right now in this equation. What mass of calcium oxide is produced when 10 grams of calcium carbonate is heated? Guys, can you look at there right now? I have told you to calculate the moles first. So we can say this thing that 100 grams of calcium carbonate is equal to 1 mole. How I am saying this thing? Because when I am writing for calcium, it is 40. For carbon, it is 12. And for oxygen, it is 16 times 3. So the total of this whole thing will become 100. Okay. So I can say this thing that 100 of calcium carbonate is equal to 1 mole, whereas 10 of calcium carbonate is equal to 0.1 mole. So we have just calculated the moles first, which is equal to 0.1 in that case. And the next step, we can say this thing that 1 mole of calcium carbonate is giving you 56 calcium oxide. How we know this thing that it is 56? I'm writing here, it is calcium oxide, which is 40 plus 16, and the total is 56 in that case. So I can say this thing that this is 56, whereas this is 100. So here it is. Okay, so 100 1 mole is giving you 56 calcium oxide, whereas examiner is asking for the 10 gram, and I have calculated here that 100 grams of calcium carbonate is equal to 1 mole. So 10 grams of calcium carbonate will be equal to 0.1 mole. I can say this thing that 1 mole of calcium carbonate, according to the balanced chemical equation, is giving you 56 calcium oxide, whereas 0.1 mole of calcium carbonate is going to give us 5.6 grams of calcium oxide. So this is the answer, option C, for question number 5. Now we are on question number 6, which is a little easier. I should say this thing that it is easier as compared to number 5, because it is not calculation based, but it is a little more tricky. Other way we can say this thing. If we are looking into this question, I am going to zoom it a little bit so that everyone uh, can find it easier to read it. Okay. Now for this question, gas syringe X contains, I am just spotlighting it, gas syringe X contains 100 centimeter cubes of HBr, hydrogen bromide gas. Gas syringe Y contains 100 centimeter cube of carbon dioxide. We can highlight few of the points. So this is X, this is Y, and that is 100, that is 100, that is HBr, and that is carbon dioxide. Okay. So the volume of each gas is measured at room temperature. Might be examiner will not give you the formula of HBr in your paper. So please be careful about that. The simpler formulas must be in your mind. Hydrogen bromide formula is matching with hydrogen chloride, which is hydrochloric acid. So hydrogen bromide is also called as hydrobromic acid. So it's a combination of hydrogen and halogen. So which statement is correct? The mass of HBr is less than the mass of carbon dioxide. No, first of all, one should know this thing that mass of HBr is 81. How we know this thing that H is 1 and Br is 80 in the periodic table? When we are going to sum up this thing, that is 81. And what about the mass of carbon dioxide? It is 12 plus 16 plus 16, which is 44 here. Okay, so it means that first option is wrong right now. Next option, the number of molecules of HBr equals to the number of molecules of CO2. Yes, we can say this thing. We have studied this concept in the moles of gases, that ratio of moles is equal to ratio ratio of volume in case of gases, as the volume of both of the syringes is equal. One gas syringe has 100 centimeter cube, other gas syringe has 100 centimeter cube as well. As their volume ratio is same, it means their mole ratio will be same as well. So that's why we can say this thing, that when mole ratio will be same, number of molecules will be same as well. I am taking you back to the Avogadro's concept. We can say this thing, that 1 mole of average substance occupies volume of 6.02 into 10 to the power 23. Okay, 1 mole of every substance has the same number of particles, which is 6.02 into 10 raised to power 23. Okay, so if we are going to calculate the moles of 100 centimeter cube of one and moles of 100 centimeter cube of the other, the mole value will be same. When their mole value will be same, their number of molecules, their number of particles will be same as well. So that's why we can say this thing, that in 100 centimeter cube of HBr and in 100 centimeter cube of CO2, both of them will have same volume, same mole, and same number of molecules as well. Then the C option, why C and D are incorrect. The gas syringe in X contains more atoms than gas syringe Y. OMG, we are going to write X and Y. Okay, let's see over there. So this is X, which is like this I am writing here, and this is Y. Examiner is saying that X contains more atoms than Y. No, this is wrong. Why it is so? Because X has HBr, which is having two atoms in this. One is H and one is Br, whereas Y has three atoms in it. One is carbon and two oxygen atoms as well. So overall, three atoms are there in Y. That's why C option is wrong. Look into the D option right now. The number of moles of HBr is more than the number of moles of HBr is more than the number of moles of CO2. It is the same point which I have just explained you to explain B point as well, that as their volume ratio is same, so their molar ratio will be same as well. Their molar ratio cannot be different from each other. That's why B is the right option for question number 6. Okay, right now I am on question number 7, guys. Question number 7 is one of the rarely asked question, I must say this thing initially, but nowadays, as the paper like a question asking criteria is getting difficult, and difficulty overall is getting higher, so that's why I would like to inform you very clearly that such type of the questions are now a frequent part of the paper. So please be focused on a question, and I have this working is a sufficient proof that I am trying to explain this question till the limit. So please look at the question carefully and consciously right now. Okay, so examiner is saying in this question, okay, chlorine gas will react with iron metal. Okay, done. Exactly 21.3 grams of chlorine reacts with 11.2 grams of iron. Okay, how many iron atoms react with 30 molecules of chlorine? First of all, we are going to calculate the moles of chlorine. Okay, so first of all, what is the moles of chlorine? Moles is equal to mass over mr, so it is 21.3 divided by 71. Okay, Cl2 is the chlorine gas, and we have taken as 71. Okay, done, and that is 0.30. Now we are going to calculate the moles of iron as well. Mass of iron is given, which is 11.2, and we are going to divide it by its AR value, which is 56, as iron is not diatomic. Okay, and we really don't know that either in a balanced chemical equation it is 2 or 3 or 5 or whatsoever. Okay, so we have just calculated it, and that is 11.2 divided by 56, so that is 0.200. So we have the moles of Cl2 and we have the moles of Fe as well. What is the ratio between 0.3 of Cl2 and 0.2 of Fe? That is 3:2. According to this molar ratio, we have just developed a balanced chemical equation between iron and Cl2, which is giving you 3Cl2 plus 2Fe, which is giving you 2FeCl3. Okay, done. Now it is the moles of Cl2 in 30 molecules, which we are going to calculate it. Okay, so just look at there right now. It is like 30 divided by 30 molecules. So they are just giving you 30 for this. Okay, so from this till this working, we are just calculating this ratio method to calculate the Fe. Basically, we are just calculating the moles in this that we can calculate before this as well. Okay, before this working, we can calculate this, but to reach this destination, we have to calculate this whole process. Okay, so how many moles of Cl2 in 30 molecules? We can say this thing that 6.022 into 10 raised to power 23, we are going to divide it by this, and as a result we are going to calculate the moles in this. We can say this thing that 1 mole of Cl2 will be having how many 6.02 into 10 raised to power 23 particles in it. So like a 30 molecules will have how many moles in it. So it's like moles we are going to calculate. I am just writing this explanation again with the red pen at the top so that everyone can be more convenient about this. We can say this thing that 6.02 into 10 raised to power 23 of Cl2 are equal to 1 mole. So it is like a 30 Cl2 molecules will be equal to X. So it is like 30 times 1 divided by 6.02 into 10 raised to power 23. So this is the working from this. Okay. So it's like 4.98 times 10 raised to power minus 23, which is the moles of Cl2 in 30 molecules. So we have just calculated the moles of Cl2. So according to this mole ratio and this implementation, we have just reached this thing that what will be the moles for Fe, which is like 2 ratio 2 divided by 3, 2 divided by 3, because we are going to calculate the moles for Fe. So it is 2 divided by 3 times these moles which we have calculated for chlorine. So when we have calculated that, it is equal to 3.32 times 10 raised to power 23. Now we are going to multiply these moles of Fe with the Avogadro's number, and as a result, we are going to calculate the atoms of number of atoms of iron which are going to react with these chlorine molecules. So first of all, we have calculated moles of chlorine, moles of iron. From the moles of chlorine and moles of iron, we have just calculated the ratio of moles of chlorine and moles of iron. The ratio is just helping us to find out the balanced chemical equation between the two, and then we have calculated the number of moles of chlorine in given molecules of chlorine. From that moles, we have calculated the moles of iron. From that moles of iron, we have just multiplied by Avogadro's constant to calculate the number of atoms of iron. So this is the whole procedure. It's a whole lengthy process to calculate such an MCQs. Might be some of the students are thinking that all of the MCQs are requiring this much working. No, no, no. Please don't get upset. All the MCQs are not requiring this much working. Barely one or two MCQs out of the whole total thingy are involving this much working. But those students who are just practicing such type of the questions like 2 or 3 times more, things will become much easier for them. And I am going to continue with the practice of the past papers, inshallah. See you in the next video. All the best.